Okay, we'll continue with the problems. Evaluate integral 0 to 2 pi cos 2 theta by 5 plus 4 cos theta d theta. So here we know what is d theta and we know what is cos theta, and cos 2 theta is what we have to learn now. So all the other substitutions are same. Okay, e raised to I theta cos theta z square plus 1 by 2z and the d theta is dz by iz. Now z is equal to e raised to I theta. If this is theta, okay, e power I theta. Z square is equal to, let us find z square. So what will be z square is equal to e power I theta the whole. Z is e power I theta. Z square is e power I theta the whole square. That is e power 2i theta. Now z square is equal to what is e power I theta? Cos theta plus I sin theta. Therefore, using this we can write e power 2i theta. E power 2i theta means instead of theta you take 2 theta. Okay, because e power I theta is cos theta plus I sin theta. Therefore, e power 2i theta is 2i theta. You have extra 2, right? Instead of theta you have 2 theta. So cos 2 theta plus I sin 2 theta. Now what is cos 2 theta? This is a real part. This is imaginary part. So in our question we have cos 2 theta, that is real part of z square. What is cos 2 theta? Real part of z square. So we write cos 2 theta as real part of z square. Okay, cos 2 theta is real part of z square. So if you know this much, then you can follow the same method which we learned earlier. So this is the difference here. So now let's consider the question. Integral 0 to 2 pi cos 2 theta by 5 plus 4 cos theta d theta. So cos 2 theta real part of z square. So numerator real part of z square. D theta dz by iz. 5 plus 4 cos theta is z square plus 1 by 2z. Now this real part is taken outside. Z square into dz by iz. Here you find the LCM. 2 5s are 10z plus 4z square plus 4 by 2z. Okay, just simplification. Now we write this next step. Z square dz plus iz into if you put into this denominator will become reciprocal. That is 2z by 4z square plus 10z plus 4. So ordinary simplification. You can write this into, write the reciprocal. So now here this 2z, here 1z will be eliminated. Okay, so 2z square by the remaining term, then dz by I. So this 2 by I, here can you cancel any more terms? Yeah, I will simplify it further. You can take common term. From this you can take 2 as a common term. So this is not z, this is 2. Okay, make it as 2. 2 into this is 2. 2 into 2, 5, 2. 2, 5, 2. So now this 2 and this 2 will be eliminated. So you have only 1 by I. 1 by I integral 0 to 2 pi z square by 2z square plus 5z plus 2 dz. Now f of z dz. What is f of z? Now we make it as f of z. So real part 1 by I integral 0 to 2 pi and what about f of z? Z square by 2 z square plus 5z by 2 into dz. So this particular term we assume as f of z. Okay, f of z is z square by 2z square plus 5z plus 2. So 2z square plus 5z plus 2 is equal to 0. We get the poles minus 1 by 2 comma minus 2. So you can use the formula minus b plus r minus root of b square minus 4ac by 2a. You get these two values. And since it is unit circle, radius is 1 and this is less than 1, so it lies inside. This modulus value is greater than 1, so it lies outside. For inside value, let us find the residue. So you know how to find residue, right? So you can apply that formula and you find the residue. And once you split this, you should be careful. Denominator, since the roots are these two terms, z plus 1 by 2, z plus 2. Also, since you have 2 here, 2 should be taken as a common term. That's what you have to remember. This 2 should be taken here. Then z minus of minus 1 by 2, z minus of minus 2. Now here this will be eliminated. Then after substituting z as minus 1 by 2, you get the answer as 1 by 12. Now by Cauchy integral theorem, we get 2 pi I sum of residues, 2 pi I 1 by 12, that is cancelling 2 and 12, pi I by 6. Now we substitute this in equation 1, that is here. Okay, this is our answer, real part of 1 by I, integral of this. Now integral of this, just now we have found integral of this. So multiply that value by real part 1 by I. So 1 implies real part 1 by I into integral, this is equal to real part 1 by I into this integral value is pi I by 6. Now here I and I will be eliminated, we get pi by 6. So real part is, so finally we have to take the real part. There is no imaginary part. I and I will be cancelled, so pi by 6 is the answer here. So next question, I will give you the hint, you can do that, okay. The difference is value of sine square theta, remaining there is no difference. So what is sine square theta? 1, we have the formula for sine square theta, 1 minus cos 2 theta by 2. This is 2, okay. 1 minus cos 2 theta by 2. So this 1 by 2 can be taken outside. So integral 0 to 2 pi 1 minus cos theta cos 2 theta, okay. So let me write that here. Sine square theta is 1 minus cos 2 into theta by 2. So you can have that 1 minus cos 2 theta, then denominator 2 plus cos theta you have. So this 1 by 2, okay, this 1 by 2 is taken outside here, So now what is cos 2 theta? We have derived this in the previous problem, okay. Cos 2 theta we have derived in the previous problem, real part of z square. So now we can follow the same method here. Instead of cos 2 theta, real part of z square you substitute. Then remaining same substitution. Then again this real part can be taken outside, okay. Real part by this 2. Therefore 1 minus z square will be there. Real part is taken outside, 1 minus z square. Here you take the LCM. Then you can cross multiply 1 minus z square into this become reciprocal 2z by denominator into dz by iz. Then again you can try to cancel the term. Here 1 by I is z. Here you have 2, and so already you have a 2 here, right? 1 by 2 is here. Then you can take this I outside. So I into 2, you have 2i. Also you can take this 2 outside. You have 2 here. What remains? 1 minus z square dz, z square plus 4z plus 1 in the denominator. Now so this z and this z will be eliminated. So you get this. Now here 2 and 2 will be eliminated. So you get this. Now you can continue with the same method. This term is taken as f of z. You find the poles, okay. You find whether it lies inside, or you can do it on your own. You can find whether it lies inside or outside. For inside point you find the residue, which is familiar to you. You find the residue, and by Cauchy residue theorem you get 2 pi I into sum of residues. Now from equation 1 you substitute this in equation number 1, that is 1 by I into this value, real part by I into. So you get real part by I into, what about this value? 2 pi I into 2 minus root 3. So here I and I will be eliminated. So here real part, there is no imaginary part. So 2 pi into 2 minus root 3 is the answer to this question. So now type 2, integral minus infinity to infinity f of x dx, where f of x is g of x by h of x. G and h are polynomials with the degree of h exceeds degree of g, okay, by at least 2. So degree of h will be greater by at least 2. In this method, no poles of f of x lies in real axis. Choose the curve gamma of the real axis and r minus r to r and the upper semicircle. So that means here you see this is the curve here. In this method it will be a first you should identify there is no cos theta and sin theta. Only x will be there, okay, polynomial. Also it is a semicircle. Here the contour C is a semicircle, okay. In the previous method C is unit circle, but here it is a semicircle, and semicircle with a radius. That means it extends from minus r to plus r. Okay, radius extend from minus r to plus r, and this semicircle is taken as gamma. Okay, this much is the contour, and now integral gamma f of z dz. That means this when you take line integral, we have to add both the case, that is integral minus r to r f of z dz plus integral over c f of z dz. When integral over c f of z dz, and this integral tends to 0 as r tends to infinity. When r is very large, okay, this region will vanish. Therefore, integral over c f of z dz, this particular value tends to 0 when r is infinity. So we get integral, this value is not there. So we get integral r becomes infinity. Minus infinity to infinity f of z d, f of x dx. This is x, okay, f of x dx is integral gamma f of z dz. So this is equal to integral minus r to r f of x dx, okay, this is f of x dx. And when this is 0, this becomes minus infinity to infinity because r tends to infinity. Then here no change, integral gamma f of z dz. So now we'll continue with the problems. Show that integral minus infinity to infinity 1 by 1 plus x square dx is pi. So we know this is f of x form, f of x by g of x. So we should understand this is type 2. Let gamma is a closed curve. Okay, closed curve consisting of upper semicircle and the line minus r to r. Okay, upper semicircle and minus r to r. And in this method, integral minus infinity to infinity f of x dx is integral over gamma f of z dz. So just now we learned. Okay, we are taking this equation, and now let f of z be the question, 1 by 1 plus z square. So now we find the poles, equate denominator to 0, z square is minus 1, z is plus or minus I. So after finding, we have to verify whether it lies inside or outside. I means here real part is 0, imaginary part is 1. 0, 1 you can plot 0, 1 here. Minus I means real part is 0, imaginary part is minus 1. So 0, minus 1 you can plot in this graph. Then, okay, likewise when you plot 0, minus 1 lies outside, it lies here. So it lies outside the semicircle. 0, 1 it lies here. So I lies inside, minus I lies outside. Minus I outside, I inside. So I lies inside, you can find residue. Since it is simple pole, we find the residue using this formula. A is I. So you get f of z is 1 by 1 plus z square. You can split this because roots are I and minus I. So you can write it as z plus I into z minus I, this denominator. Okay, f of z denominator can be splitted. Cancelling z minus I, you get 1 by z plus I. Now z is I plus I is 2i, 1 by 2i. So after cancelling this, applying limit, you get this. By Cauchy residue theorem, we know integral value is 2 pi I sum of residues. So 2 pi I, residue is 1 by 2i. So here cancelling we get pi. So we get the answer, that is from equation 1. What is equation 1? Integral minus infinity to infinity f of x dx is integral gamma f of z dz. Now what is integral gamma f of z dz? Pi. So value is pi, that is integral minus infinity to infinity f of, what is f of x? 1 by 1 plus x square. 1 by 1 plus x square dx. That is our question, okay? That is our question. So we have proved this is equal to pi. Pi, that is the type 2 method we have followed, and we have proved the integral value is equal to pi.